During the recording process, a neuron was injected with a dye, and this dye was subsequently made visible through an immunocytochemical technique. This is a two-dimensional projection of a neuron, which we are going to study closely before we reconstruct it. We see the round soma as well as the extensions coming out of the soma. Some of these extensions have small spines, and we know right away that they are dendrites because the axons are smooth in appearance. There are many dendrites with spines. They are like little points coming out of the dendrites. And here, in an axon, because you can see it, it looks very smooth. Now let us look at a three-dimensional image. What we need to do is take off from the cell body, and we follow. This you cannot see very well because the trace is blue against the green background of the neuron, but the spines are very visible here. We continue until we are off of the image. We go back to the point of the bifurcation, and from there we follow the branch that emerges from the dendritic trunk, which is in the second branch and which stops here. It should be noted that in sections, neurons are inevitably cut because sections are 400 micrometers thick, and a neuron's dendritic tree could be much larger than this. It can go up to 1 millimeter in diameter, and some dendrites are cut because they are at the end of the section. Here, we can see another bifurcation. The branch is not very large, but is worth pointing out. We continue along a branch. When we are done with this branch, the program will take us directly to the bifurcations that we have marked. We then follow all of the neuron's dendritic branches. Let us outline an axon now. It takes off upward, and we follow it again by adjusting the Z in the same way as before. Here is the neuron outline. The dendritic tree is white and blue, and the axon is violet with two rostrocaudal branches. The program enables us to turn the reconstructed neuron in 3 dimensions, and then we see that it is very flat, no thicker than the section. We can see a small dendritic tree and a long axonal branches. This type of experiment provides an insight into the morphology of a neuron and an understanding of the relevant numbers, i.e., the number of dendritic trunks, branching, and dendritic terminals. It provides insight into the structure of the axon. Is it a single axon? Does it give off collateral branches? Does it have only 2 child axons, etc.? And a comparison with neurons within the same structure to see, for instance, whether neurons are different or whether there's only a single type of neuron within this structure.